Okay, let's start with section 9.1, factors and the greatest common factors, page 474 in your book. First of all, what is a factor? Well, if you remember that when we multiply two numbers together, such as 3 times 4 equals 12, the 3 and the 4 are called factors. The 12 is called a product. Okay? So what we're talking about today is the factors, how to figure out the 3 and the 4. Okay? So factoring is that concept of taking the number 12 and figuring out what numbers multiplied together equal 12. And the method you learned in second or third grade is the factoring table. It always starts with 1 times the number. 1 times 12 equals 12. All right, well, let's go up 1, and let's say 2. Well, 2 times 6 equals 12. Go up again, 3 times 4 equals 12. And then I could go up again, go to 4 here, but once I reach 4 on this side, or the number on this side that I've already got on this side, then I know I'm done. So my factors for 12 are 1, 2, 3, 4, 6, 12. Let's do another number. Let's do a number like this, 7. What is its factoring table? Well, we always start with 1 and the number. Well, 1 times 7 is 7. So we try 2. Well, 2 doesn't go into 7 evenly, so let's try 3. 3 doesn't. 4, no. 5, no. 6, no. 7. Well, 7 is already appears here, so we know we're done, and so this number is done. There's a special name for numbers like this, where when you factor them, the only thing that factors into them is the number 1 and themselves. These numbers are called prime. Okay? Well, if these are called prime, what about this one that has multiple numbers that become factors? Well, this has a special name too, that is composite. So this number here is a composite number. 12 is a composite number. 7 is a prime number. Let's try a couple more. Let's say 36. I'm doing my factor table. I'm going to start with 1 and 36. I go up by 1, so I say 2, and I know 2 goes into there. 2 and 18. 2 times 18 equals 36. Does 3 work? I think about it for a while, and I say, yes, it does. 3 and 12. How about 4? 4 and 9. How about 5? No. How about 6? Yes. 6 and 6. And now this number is equal to or bigger than the number here, so I know I'm done. And so my list of numbers that are factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And then I can say, well, because this has more than just the one pair of numbers, this is a composite number. And let's try a bigger number right here, 23. We know that start with 1 and 23. Let's try 2. No, 2 doesn't go into 23. 3, no. 4, no. 5, no. 6, no. Matter of fact, we just keep going all the way up to 23. No number goes into 23. And this is our end of our factor table. We know this is a prime number. All right, that leads us to the next concept of prime factorization. Okay, when you're doing prime factorization, that's breaking a number not just down like here, this is factoring, but I want to break it down into all the numbers when multiplied together, and all the numbers when multiplied together have to be prime numbers, and they'll equal that number. So, I'm going to show you two different methods. First method is called the horizontal method. Let's say I have the number 90, and I want to break it down into its into its prime factors. Well, I can say that it's 2 times 45, 2 being a prime number. Okay? So then I'm going to say, well, I'm going to break the 45 down now. 2 is good enough. It's a prime number, so I'm going to repeat it. Now 45 is, let's say, 3 times 15. 3 times 15. The 3 is a prime number, so that one stays. So I've got to break down the 15 now. So 2 times 3. Well, 15 is 3 times 5. And I've broken it down. And now I look at all my numbers, 2 and 3 and 3 and 5. Those are all prime numbers. And that's my final answer. There is the prime factorization of that number. Now let's do it in the tree method. Tree method, basically what you do is you start with your number, 90, and you draw a tree. You break it down into its parts. Let's say you can break it down into any part. I'm going to break it down to 9 and 10. Then 9 I'm going to break down into 3 times 3, and 10 into 2 times 5. And now if you look, if I order that in the right order, 2 times 3 times 3 times 5, the bottom of my tree is my prime factors. And notice that this answer is the same as that answer. Okay? And one of the things when you're doing the tree, you can break it down many different ways. Let's just do the tree, and let's do 3 and 30. And then 3 and 10, and then 2 and 5. You'll notice that I have 3 times 3 times 2 times 5, and that's the same numbers here. So when you write it, finally, you always write it smallest to largest, but I'd get the same answer even though I used a different method of walking through the tree. Let's do it one more time. Let's say I did 90, 2 and 45, 3 and 15, 3 and 15. And you'll notice that when I did this one, all the numbers are in order. 2, 3, 3, 5. Oops, sorry. 2, 3, 3, 5. Okay? And that is actually the same thing we did horizontally. We went 2 and 45, 2 and 45, and we broke the 45 down to 3 and 15, 3 and 15, then we broke the 15 down to 3 and 5, 3 and 5. Okay, but they all get the same answer. All right. Okay, what is this form right here? Either one of them, but it has a special name. It's called the factored form. So what that means is if you're asked to do prime factorization of the number 90 and give the answer in factored form, you're going to multiply all the way out. Okay? Sometimes you'll see that in this form. And you'll notice instead of writing 3 times 3, they wrote 3 squared. Okay? That is not factored form. Although it's still a valid answer, it's not the factored form of the answer. Okay. What happens if I have a negative number? How do I handle a negative number? How do I handle a negative number? Well, it's not very difficult because there's only one rule change. Let's say I have 140. I'm going to use the tree method here. First thing you do, let's get rid of the negative by factoring out -1. And now I can just break this down into however I want to do it. And you see that I've broken it down into -1, 2, 2, 5, 7. The bottom of my tree is my prime factorization factored form. So -1 times 2 times 2 times 5 times 7 is the factored form of -140. All right, let's take a look at example number 4. In example number 4, we're starting to talk about monomials, okay? So let's look at 4a. How do I factor out a monomial? Let's say I'm given 12a squared b cubed, okay? Well, it's pretty simple. You do the number just like we did before, 2 and 6. I'm using the tree method, 2 and 3. So I know that 2 times 2 times 3 is going to give me 12. So there's the factored form of the number. Well, the variables are pretty simple. They just break right down to a times a and b times b times b. So you just multiply how many ever times their power is, and there is the factored form of that monomial. How about another example, 4b in your book? Negative 66p q squared. Okay, well, let's do it again. Tree it, negative 66 and 0. Negative number, always do negative 1 first. And let's say 3 and 22 and 2 and 11. So my numbers are going to be negative 1 times 2 times 3 times 11. Now my variables are p and two different q's, because it's q squared. And there is my factored form of negative 66p q squared. Okay. Now, let's go on to a concept called the greatest common factor, or GCF. What is GCF? Well, it's the greatest number that can be divided into two numbers evenly. Okay, so let's say I have to start with two numbers, and let's say I start with the numbers, let's say 15 and 16. Okay, what is the biggest number that is common between both of them? Well, let's not